Hello guys, in this class now, let's now discuss a man on a lift, and this will be our lesson 14. So a man on a lift, what happens to a man when a man is on the lift? Either the man is going up or the man is coming down. Now, let's first of all start by giving a mindset. Let's say it's a lift, and a man is inside the lift. Now, when a man is inside the lift, you can see that the lift itself has a rope, right? Now, if the man is inside the lift, there are two forces acting on this lift. Please follow the class. It is very interesting and mind-blowing. There are two forces acting on this lift. Number one, the force which is the man's weight, and that force is acting downward. That force is called the weight. So the weight of the man is practically pushing downward, is moving downward. Are you seeing that? The second force that acts on this man in the lift is called the tension. Either we call it the tension or you call it the reaction. The tension is simply the tension of the floor of the elevator. You can see that one is acting upward. Of course, what should come to your mind, Newton's third law, which is action and reaction. They are equal, but they are opposites. So number one, the weight of the man, which is acting downward, and number two, the tension or the reaction of the floor of the elevator, which is acting upward. So these are the two forces that act on a man in a lift. So if they ask you in any exam, what are the two forces that act on a man in a lift? Number one, you tell them the weight of the man, which is acting downward, and the tension or the reaction, which is acting upward. Now, also when a man is on the lift, what is used to measure weight of a man? The weight of a man is measured by our spring balance. So the spring balance, at every point we have to tell you, okay, what is happening now? We're going to talk about that. So if you say you understand that, let's move. Let's explain that just what we have discussed. We said that when a man is on the lift, practically there are two forces acting on the man. The first force is what we call the downward force, which is the man's true weight. And number two is what we call, and the weight is given as W is equal to what? To mg. And number two is what we call the upward force. And what's the upward force? Which is called the reaction. And it is simply the tension. Either you say reaction or you call it tension, and it is acting upward. So what are the two forces acting on the man? We said the man's true weight, which is the downward force, and we said the upward force, which is called the reaction. Do you understand that? Now let's now go back. In studying a man on a lift, there are four things that should come to your mind. So a man on a lift is being measured by, the weight of the man is measured by the spring balance. We explained that the weight of the man is measured by spring balance. And when a man is on the lift, there are four things that we need to note that happens to this man on the lift. The first thing is what we talk about is the lift moving upward. Is the man moving upward? Two, is the lift moving downward? Three, is the lift stationary? And number four, it is when the rope cuts in the lift, that's free fall. So when a man is in a lift, what are the four things that come to your mind? Is the lift moving upward? Is the elevator moving upward? Is the elevator moving downward? Is the lift or the elevator stationary? And what if the rope of the elevator cuts? Now, if you say you understand that, let's treat them one after the other. The first one is if it is moving upward. Now, give me that man on a lift. Take note that if the man is on a lift and the lift is moving upward, two things should come to your mind. Of course, there are two forces acting on it. The first thing to know is that the force acting downward, which we call the weight, this is the weight. And the second thing to know is the tension. Now, what can you see? If the man is moving upward, it means that the tension of the man is greater than the weight of the man. For the man to go upward, it means that the tension of the man is greater than this. You can see the arrow. This arrow tells you the tension. The tension of the man is greater than the weight of the man. So that means there's an unbalanced force. What I say, there's an unbalanced force. So if the man is going upward, we are practically going to say F, which is the unbalanced force, is equal to the tension of the man minus the weight of the man. We said that as the elevator is moving upward, you can see that the tension is greater than the weight. For the man to go upward, the tension is greater than the weight. That means this force is called the unbalanced force, because if you watch, this thing now is greater than, let's say for example, the man's weight now is, let's say the man's weight is 10 Newton. For this man to go upward, the mass tension will be let's say 100 Newton. That means there's an unbalanced force. That unbalanced force is F is equal to what? This tension minus the weight. So that's how we see F is equal to N. But from here now, we can decide to make T so the formula. What will be T? T will practically give us W plus F. And what is W? W is the weight of the man. Weight is equal to mg. And what is force? Force is equal to mass times acceleration. So we can say that the tension will be equal to mass acceleration plus mg. Mass is common. So we say that the tension is equal to mass equal to E plus G. This is the formula when a man is moving upward. We first of all said that the force, the tension will be greater than the force because of the amount of that, and there's an unbalanced force, that's F is equal to T minus W. And we know that. Now the second thing to note, this is the first thing to note, which is the formula. The second thing to note is that as the man is moving upward, we now say that a new weight is formed. This is the weight 1, and this is the other weight. So we can say that the weight 1, this is the second thing to hold. The weight 1 is greater than the man's weight. So what happened? Because the weight 1 is greater than the man's weight, the man is going to appear heavier on his spring balance. Please understand it. So two things. When a man is moving up on number 1, take note that T is equal to M into A plus G. And the second thing to know that the man will appear heavier than his actual weight. Are you seeing? So the man, the tension of the man is higher than the man's actual weight. So the W1 is greater than what W. Now let's put it into writing.
Hold on a bit. The complete series of classes, right, as far as your syllabus is concerned regarding your Jamb And Waec, everything has been covered in details for you in the LearnLift app. And guess what? The sweet part is that you have access to your CBT, right? You have access to your video lessons, you have access to your notes, you have access to your past questions. Everything from the beginning to the end is directly in the LearnLift app for you. So all you have to do is just mark down to Play Store or App Store and download the LearnLift app where you follow all your classes from the beginning to the end. A quick one before we move. Let's get back to class. Enjoy.
So you can see, we said that if a man is moving upward, when the elevator is moving upward, the tension, which is the upward force, is more than the man's weight. That's the upward force is greater than the downward force. Therefore, there's an unbalanced force. And what would that unbalanced force give us? We said that the unbalanced force will give us T is equal, F is equal to T minus your W, where your W is the weight, which is W is equal to mg. From here now, if we make T so the formula, the T comes here, it's going to be F is equal plus mg, where mg is the weight of the man, and F is the what? The unbalanced force. So since F is equal to ma, we said practically it will give T is equal to ma plus mg. And since m is common, it's given as a and what? This was the first thing we said. And the second thing we now want for that to make you understand is that we said that the apparent weight will be bigger than the mass true weight, that means W1, because it is moving upward. The apparent weight is the tension. The tension is telling us that the tension is bigger than the mass weight. So that means the man is going to appear what? Heavier. You see now, or you say the man is going to appear what? Bigger, or the apparent weight is what? Bigger. Past question, we're going to strike that. Let's see what if the man is moving downward. Now, give me a lift. The man is in the lift. If the man is moving downward, now give me the tension and the weight, which will be bigger. Because the man is moving downward, the man's weight is heavier. That is why the weight, the elevator is moving down. Do you understand? So this is the man's weight, which is bigger, and this is the tension. So of course here there's also an unbalanced force. What will be the unbalanced force? The unbalanced force F will now be equal to, who is bigger here? The weight is bigger. That means the weight W minus the tension. Are you seeing that? And don't forget that this is, if you make tension instead of formula, this now become tension is equal to weight minus force. Is that correct? So therefore, it now become tension is equal to mg minus ma. Are you seeing that? So we can say that T is equal to m into g minus a. Are you seeing that? So this now becomes T is equal to mg minus a. This is when the man is moving downward. T is equal to mg minus a. So the first thing to note. Now what can you see? The weight, which is this, is bigger than the tension. So we can say that the second thing to say that the man's weight is greater than the apparent weight. So the man is going to appear what? Lighter. We are taking this as the apparent weight because the man's weight. So the man will appear what? Lighter on the spring balance. Are you seeing that in the first case the man is appearing bigger, in the second case, when you hear that a man on the lift is appearing lighter, know that the lift is moving downward. Do you understand that? Now let's still explain that, putting that in writing. We went for that to say that when an elevator is moving downward, the tension, which is the upward force, is less than the weight. Therefore, there's an unbalanced force. That unbalanced force now become what F is equal to the weight, which is greater, minus the tension. Therefore, if we make tension so similar, tension will now be equal to weight minus F. You know what weight? Weight is mg. Force is what? Ma. And we say that it now become mg minus ma, which is equal to T is equal to mg minus A. Do you understand? So no, when it is coming down, when it is going up. As you seen that, we said when it is coming down, we said T is equal to m into A plus G. This is when it is going up. But when it is coming down, T is equal to m into G minus. Do you understand that? Now, what we said is spring balance. The spring balance will show you lesser weight. Is that correct? The spring balance show that means the man will be what? Will be lighter. And therefore, moving downward appears to be what? Lighter, because we said W will be greater than W2. And that's Jamb 2011 question 4. We're going to see the question, but let's still move forward. Now, the third thing is if the lift is stationary. If the lift is stationary, it means it is neither moving upward or downward. That means it's not accelerating. So give me a manual lift. Now that means for the lift to be stationary, it means that the weight will be equal to the tension. This is the weight and this is the tension. Both of them are equal stage. Now, if it is stationary, the first thing that should come to your mind is that acceleration is equal to 0. 1. And if acceleration is equal to 0, what does that tell you? For acceleration to be 0, we've done a velocity time graph. If acceleration, what's acceleration? Acceleration is velocity over time. If acceleration is equal to 0, it means that your velocity is constant. That's a constant velocity. So from here now, what will happen? We said that the tension will be equal to the what? To the weight. You can see both of them are same. There's no balanced force. So tension will be equal to the weight. So that means the weight will be equal to what? Mg. You see now. So if the man stand on the spring balance, the man is going to show his exact weight. Exact weight. So when you just hear that acceleration is 0, or you hear that it moves at a constant velocity, what should come at a constant velocity? If this is a time graph, this is what is moving. This acceleration is neither accelerating nor this thing. Acceleration here is equal to what? 0, because it has a what? A constant. This is the velocity what? Time graph. You can see that the velocity is just at this point. So when you hear that it has a constant velocity, acceleration is 0, that means it is neither accelerating nor decelerating. And what will be it on the spring balance? The man is going to add its exact weight. Do you understand that? Please take note of this word. We went further to see that if the lift is stationary, it means that it's neither accelerating nor decelerating. A will be equal to 0. And we also say that meaning it has a constant velocity. When you hear that it has A is equal to 0, a constant velocity, what should come to your mind? We now said that the weight will be equal to the word tension, which will be equal to what? To mg. And we said if the man is on the spring balance, what should come to your mind on the spring balance? There's no unbalanced force. So the man standing on the spring balance will show the man's what? Real weight, because there's no unbalanced force. Because there's no unbalanced force, the spring balance will show the man's weight. Do you understand? Now the last one is elevator. Let's say the rope cuts. If the rope cuts, what happens? Give me the elevator. If the rope cuts, the man will be falling freely. And if the man is falling freely, what should come to your mind? Free fall. We've talked about free fall. What is free? In free fall, we said acceleration is equal to acceleration due to gravity. Because what will be the acceleration? Now, hope you know that if F is equal to ma and weight is equal to mg, there is difference between this. In weight, acceleration is constant, which is equal to 10. But acceleration can vary. It can be 2, it can be 3, it can be anything. So, but when the object is going free fall, A will be equal to G. And if A is equal to G, let's see what we have now. Give me the formula when the weight. Remember that if the rope cut, will it be falling upward or downward? It will be falling downward. So what is the formula for tension when an elevator is falling downward? We say that the formula is given as T is equal to M into G minus A. We prove that, right? So if A is equal to G, that means we can say that T is equal to M into G. What is now A is G? That's G minus G. So T is equal to M equal to what? 0. And T, what is T times 0? That's the tension will be equal to 0. So what will the man face in the spring balance? The man is going to be weightless. This is where weightlessness comes from. The man is going to be what? Weightless. So if it was observed that a man was weightless, what should I tell you? You should know that the elevator was undergoing free fall. Please, do you understand? I took my time to explain the 4 conditions. When the man is moving upward, when it's moving downward, when it is stationary, and when there is a cut, that's free fall. If the rope of the elevator cuts down, the man will undergo what? Free fall. So this is it, and practically this is it, because it will fall down. For it to fall down, it means that the man's weight is greater than the up thrust, and that was what we got this formula from. Do you understand that? So let's also give the right thing to that. We said that this happens when the cable holding the lift cuts. It will be equal to G, because we say it's undergoing what? Free fall. That means it's going to fall free. And we know that W is equal to G minus A for downward. Downward movement. Since A is equal to G, it will now give us your what? Your weight will now be equal to, or your tension equal to mass into G minus A. That's G minus G, which is 0. And the weight will be equal to what? 0. Thus, it appears to be what? Weightless. So a man and a floor exerting no force to each other. So the scale is going to read what? 0, because both of them are not exerting force on what? On each other. And still on that note, let me also use, I'm going to also talk about this when we are discussing the next topic. We are talking about the other topic we are going to move in. Take note that people and objects in satellites orbiting around the earth are said to be weightless. People and objects in satellites orbiting around the earth are said to be what? Weightless. So for them to be weightless, you should know acceleration is equal to G. Do you understand that? Now let's see some Jamb and Waec past question. Let's start with the Jamb question. Listen to me, I've thought it now. Settle down. If you miss anyone, I'm going to look for you. I will blow you. So settle down and check what will be the answers. The first question says that a man stands on a spring balance, on a spring scale, placed in a lift. The lift descends at constant velocity. Okay, let's catch that word. Constant velocity. When it's constant velocity, that means acceleration is equal to 0, right? So when does that happen? What will the scale read? Option A say greater than the man's weight. B said the same as the man's weight. C said 0. Z said less than the man's weight. D said greater than the weight of the man by 1 kg. If it's equal, if it's at constant velocity, that means acceleration is equal to 0. And if acceleration is equal to 0, what does that tell you? It means that the lift is neither accelerating nor what? Decelerating. That means the man is stationary. And we said that when it is stationary, it will be that the upward force is equal to the what? Downward force. That means T is equal to what? T is equal to W. So what will the spring balance show? It will show the same weight as that of the wall. Now, making your option D. And did you get it? Let's take the next question. To read the question, you pause it and try to answer it on your own before we choose answer. Jamb 1986 question 15. The question says a 100 kilogram elevator is descending vertically. Is it ascending or descending? Descending with an acceleration of 10 meters per second. If the acceleration to gravity is 10 meters per second, then the tension suspending. That means they're looking for the what? For the tension. How do we solve this? First of all, we're giving the mass. This is mass. So mass to be 1,000 kilometers. We're giving what again? We're giving acceleration to be 1 meter per second. Look at it. We give acceleration due to gravity G to be 10 meters per second. So if it's moving downward, the formula tension is equal to mass into G minus A. Is that correct? So the tension now will be equal to mass 1,000 10 minus 1, which will be equal to 1,000 times 9, and that will give me 9,000 unity, making option C to become one answer. Very what? Simple. Now let's take another question. Jamb 1987 question C. The question says that an elevator of glass 4,800 as the mass is suspended by cable which can safely withstand a maximum tension of 60,000. The maximum upward elevator is as the acceleration moving upward. Now, that is very fast. First of all, is the elevator moving upward or down? What formula? We know that T is equal to N into A plus G. Are you seeing that? Now, from here, we can see that T was the tension given? T was given to me 60,000. Right, that's the tension. What again were we giving? We're giving mass to be equal to 4800 kilogram. Acceleration to gravity, of course, G will be 10. So that will give us T over M is equal to A plus G. Is that correct? That will give, first of all, 60,000 all over 48,000 is equal to 10 plus 8. So this will cancel this. She is 48,000, right? Okay, 48. This is 4,800. This is 60,000. Grab your calculator. So this will give me 12.5 is equal to 10 plus 8. So now both now become 8. A will give me 12.5 minus 10, which is equal to 2.5 meter per second minus 2. And that's my what? Option A. Do you understand that? Very simple. Let's say next question, Jamb 2011 question 4. The question says a man standing on a lift that is descending does not feel any weight. If the man does not feel any weight, that's weightlessness, right? And they said the lift is descending. So because A, there is no reaction from the floor of the lift. B said there is no gravitational pull on the man in the lift. C said the inside of the lift is airtight, and D said the vacuum in the lift is a vacuum. Well, it cannot be this. It can be this. Option A, C. Option A, C, there is no gravitational pull. Is there gravitational pull? Yes, because the rope has cut. If it's descending now, the rope has cut. That means it's undergoing free fall. That means there's gravitational pull. So option B said there's no gravitational pull on the lift. There's a gravitational pull because the man is being pulled by gravity. That's free fall. So this is wrong. Option A say that there's no reaction, making option A to become the answer. The man does not feel any weight because there's no reaction from the lift. Now quickly let's see WAEC 1996 question 10. The question says that a body of mass 2 kilograms is suspended from ceiling. Now we're in WAEC now. A lot of questions in the notes, so we're just picking some at random. Go to the note and answer all. A body of mass 2 kg is suspended from the ceiling of a lift with a string. If the lift moves upward with an acceleration, calculate the magnitude of the tension. It's moving upward. So if it's moving upward, T is equal to M equal to A plus G. So tension now be equal to 2 into what's that's 2 plus 10. That will be equal to 2 times 12, which is equal to 24 Nancy. Just know their formulas and we move. 2012 question 16. The question says get stands on the scale in a lift. If the reading of the scale is less than the weight of the man, the reading of the scale is less than. Is the man moving up or downward? It's less than. Option A say pause it and tell me your answer. Upward at a uniform speed. B said downward with a uniform acceleration. C said downward with a uniform speed. D said downward with a uniform acceleration. If the girl is feeling less than her weight, it means that she's moving downward, right? Because we'll talk about that. If it's going up, it will look bigger. If it's moving downward, it will look but smaller. Now, the C and D is smaller, but if we say uniform speed, it means it's not accelerating. So making option D to become the answer. And let's see again, practically, go to the note and solve all the questions. I've arranged all the questions under it. Don't forget, go to the note, practice CBT question and tell a friend. Always tell a friend about Learn Lift App. Always tell a friend. I'll see you in the next class. We'll be talking about what circular motion. As we round up everything about motion series. After circular motion, we'll go to simple harmonic motion, which is the last part. So that will be our lesson 15. But for now, peace out.
Hope you've enjoyed this class. Guess what? To follow up for more classes, just download the Learn Lift app, whether on Play Store or App Store, and then follow up your classes. You must do extremely well. I'll see you in class. Bye-bye.